The photochemical machining process begins with a computer-generated image of the subject part that is compensated for the etching process, and then arrayed for metal optimization. This electronic file is then photoplotted at a very high resolution and with great accuracy on a stable mylar base with a silver emulsion to produce the required tooling very quickly and inexpensively. As the tooling is generated, metal is prepared for processing. The first step requires the metal to be degreased, chemically cleaned, water rinsed, hot air dried, and rewound. Once cleaned, the metal is laminated under safe light conditions with a UV light sensitive polymer known in the industry as photoresist. The metal first passes through a contact cleaner and then photoresist is roll coated on both sides. In the printing process, the resist-coated metal and tooling finally come together. Simply put, printing is the selective exposure to UV light of the photoresist on the metal. Tooling, the top and bottom films for double-sided exposure, are first loaded into the vacuum frame. Unexposed metal is paid off an unwind unit. CCD cameras using fiducial targets plotted on the tooling register the top and bottom films within 5 microns prior to every exposure. In reel-to-reel printing, panels approximately 500 millimeters in length are sequentially exposed and advanced by precise linear motors. Again, the CCD cameras are employed to find fiducial targets printed on each panel and align each panel to the next within 13 microns. Exposure is supplied by dual 8,000 watt high-intensity UV lights with hybrid collimation. Dyes in the photoresist produce a latent image of the printed part. In essence, the polymerized photoresist darkens when exposed to UV light. Once printed, the metal is rewound. After printing, unpolymerized photoresist is selectively removed and base metal is exposed in an operation known as developing. The PLC-controlled developer is a conveyorized machine that sprays a proprietary solution that effectively removes unpolymerized photoresist. Once developed, the work goes into the etching process, where exposed metal will be dissolved in acid, while the resist protects and defines the desired part. Acid strength is regulated by monitoring and adjusting the acid's conductivity and oxidation reduction potential. Moreover, controlling the acid temperature and spray pressure leaves only the conveyor's speed to fix the metal's dwell time in the machine and ensure a consistent result. In addition, the etching machine spray nozzles are positioned on an oscillating manifold to further ensure uniformity in metal removal. Once the part is etched out, it is water rinsed and proceeds into the final manufacturing step of photoresist removal or stripping. Again, a conveyorized machine is used that sprays a proprietary, continuously filtered stripping solution, followed by a water rinse and hot air dry prior to being rewound on reels. Manufactured parts are subjected to complete first article inspections to ensure that all print dimensions are met. As a final offline inspection, all etch strip is run through a high-speed machine vision system.